All right, let's talk about 9-2. First question says, roll a six-sided die. What are the possible outcomes? Well, 1, 2, 3, 4, 5, 6. If you pull a coin from a bag full of American coins, what are the possible outcomes? Well, penny, nickel, dime, quarter, 50-cent piece, and silver dollar. A list of all possible outcomes, like we talked about last time, is sample space. For each of the following, list the sample space and tell whether the outcomes are equally likely. Do they have the same possibility of happening? Okay, so example A says roll 2 dice, record the sum of the numbers. Okay, well, kind of think of it like, well, what's the two lowest? 1 plus 1. So 2 is the sum, and then 3 all the way through 12 are the possibilities for the sum. We add up the two. Okay, and they are not equally likely. And the reason is because they don't have the same chance of happening. Rolling 2 ones is the only way to roll a sum of 2. But there's multiple ways to roll a sum of, 5. You can roll a 2 and a 3, a 4 and a 1. So they're not equally likely. Okay. Look at the next one. A family has 3 children. Record the genders in order of birth. Well, you could have boy, boy, boy. You could have boy, girl, boy. You could have girl, boy, boy. Could have boy, boy, girl. I'm going to go ahead and fill the rest of these out. Girl, girl, boy, girl, boy, girl, boy, girl, girl, and then all 3 girls. Okay. And yes, they are equally likely. They'll have the same probability. Okay. This next one, it says a family has 3 children. Record the number of girls. Well, there could be 0 girls. There could be 1 girl. There could be 2 girls, or there could be 3 girls. And this is not equally likely because the events have a different probability or different chance. All right, look at example D. It says toss 4 coins. Record the number of tails. Well, you could have 0 tails, 1, 2, 3, or all 4 could be tails. Okay, and these are not equally likely events. Okay, because there's a different probability to toss all tails and only 2 tails. All right. And the last one on this section says toss a coin 10 times, record the longest run of consecutive heads. The longest run of how many heads in a row? Well, 1 all the way to 10, because you could theoretically toss 10 in a row and 10 times. Okay? And it's not equally likely. Because you just think about it, flipping a coin, getting heads 1 time is totally not the same as flipping a coin and getting heads 10 times in a row. Not equal event. Okay. All right, look at the next section. It says, look at rolling a 6-sided die. Suppose we have 2 events. Event A is rolling an even number, and event B is rolling a number of 5 or more. Well, even number, 3 of them are even, so 3 out of 6, which is 1 out of 2. probability of event A. Probability of event B, rolling a number of 5 or more. Well, those are only two numbers that are 5 or more, the 5 and the 6. So 2 out of 6, which is 1 out of 3. Okay. What is the probability of rolling A or B? All right. Well, A or B, we have to ask ourselves, are the events mutually exclusive? Can they happen, can they happen at the same time or not? They are not mutually exclusive, okay? Because they have a 6 in common. If you roll a 6, you are rolling an even number and a number 5 or more, okay? So we have to find the probability a different way. It's not just simply addition. All right, we have to find the probability of event A, 3 out of 6, plus the probability of event B, 2 out of 6, minus the probability of both of them happening, which is 1 out of 6. So this becomes 2 out of 3 probability. Okay. If we think about this using a Venn diagram, it might make more sense. Since the events can happen at the same time, the circles do overlap. Okay, so event A are even numbers. Well, I usually try to start with the intersection. Well, the 6 is the one that happens in both events. And then even numbers that are not 6 are 2 and 4. Numbers that are 5 or more, that's not 6, is a 5. And then finally, outside the circles are the numbers 1 and 3. Okay. And then we get our probability rule number 6, which is called the general addition rule. Okay. Probability of event A or event B, notice the notation. We take the probability of event A plus the probability of event B minus the probability of event A and event B happening. And we saw that formula played out above. All right, let's look at example 2. It says, in a recent survey, 78% of people say they love dogs, 36% of people love cats, and 22% of people love dogs and cats. Okay. What is the probability that a person loves dogs or cats? All right. Well, one thing we have to think about is, are the events mutually exclusive? They are not. So we have to do the probability of dogs plus cats minus dogs and cats, which is 92%. Okay. Another thing that might help you here is a Venn diagram. Okay, so one of the circles is dogs. The other circle's cats. They do overlap because there are people that love dogs and cats. The overlapping section is the 22. 56 are the dogs. 14 is the cats, because notice they have to add up to the total. And then finally, outside the two circles, there are 8% of the people that neither love dogs nor cats. Okay, look at the next one. Probability a person loves only dogs. Only dogs. Well, if you look at the Venn diagram, you can see it's 56%. Probability a person loves only cats. 14%. Only cats. Probably a person does not love dogs or cats, and that's our 8%, okay? I would venture to bet that those questions would be a lot more difficult without the Venn diagram. The Venn diagram just makes the questions easier to answer. All right, let's practice, okay? Look at example 3. It says, suppose the probability that a U.S. resident has traveled to Canada is 18.18. To Mexico is 0.09, and to both is 0.04. What is the probability that an American chosen at random has, and then it has 3 questions. So before we do that, before we answer the questions, let's make us a Venn diagram. Okay, so we got our circles. We got Canada and Mexico. All right. Always start with the intersection. Both Canada and Mexico, 0.04. All right. Canada only, so we can get 0.18 minus 0.04 gives us 0.14. Mexico only, 0.09 minus 0.04 gives us 0.05. And then neither is whatever's left over. So 1 minus 0.14 minus 0.04 minus 0.05 gives us 0.77. Okay. Travel to Canada, but not Mexico, 0.14. B, travel to Canada or Mexico. Well, that's 0.14 plus 0.05, or another way to think about it would have been 0.18 plus 0.09 minus 0.04. Either way, the correct answer is 0.23. Not travel to either country, that's what's left over is that 0.77. Okay. All right. Right now, it'd be a good idea to pause the video and try number 4 and see if you can get it right on your own, because we just did one similar to it. So hit pause now, do it, and then you hit play. You'll see the answers. Once you get the Venn diagram, it makes it a lot easier to answer the question. So neither married nor a college graduate, 6%, is married, but not a college graduate, 50%, is married, or a college graduate, 94%. Okay. So suppose you roll a 9-sided die. Okay. First, says write the sample space. Well, 9-sided means the possibilities are 1 through 9. Find the probability that you get an odd number. So count the odd numbers. 1, 3, 5, 7, 9 are odd numbers. So 5 out of 9. Find the probability that you get a number greater than 4. Okay, how many numbers are greater than 4? 5 of them out of the total. Find the probability that you get a number divisible by 3, can be divided by 3. Well, 3 can be 3, 6, and 9, so there's 3 of them. So 3 out of 9, which actually reduces to 1 over 3. E says find the probability that you don't get a number greater than 6. Okay. You don't get a number greater than 6. How many numbers are not greater than 6? Well, there's only 3 that are greater than 6, so 6 of them are not greater than 6. So 6 out of 9, which reduces to 2 over 3. Okay. All right. Look at number 6. So suppose you roll a 9-sided die 3 times. So we got 3 events. You got to think about each event. It says find the probability that you roll 3 2s. Okay, well, 1 2 is 1 out of 9, and it happening 3 times would be 1 out of 9 to the 3rd power, which is 0.0014, just 0.14%, not highly likely. Okay, find the probability that you roll at least 1 8. Okay, so we talked about what this is like. If you roll at least, that means you could roll 1 8 or 2 8s or 3 8s, and it could be the first, or it could be the second, or it could be the third, and it could be the first 2 or the last 2. There's just lots of ways to do it, so we want to do the complement. So we're going to do 1 minus the probability that we roll no 8s. Okay, well, in order to roll no 8s, it would be 8 out of 9 or no 8. So 1 minus 8 out of 9 to the 3rd power. And probably you can use your calculator on that. You get 29.77%. Okay. And then finally, find the probability that you roll no 8s. Well, we just used that, so that should be an easy answer. couple of ways to do it. You could do 8 over 9 to the third power, or you could do 1 minus the 0.2977 from our previous answer, and we get 70.23%, no 8s. All right. That is all of 9-2.